Okay, so we're going to be talking about the types of forces. So there are going to be two types of forces. We're going to have non-contact forces such as the gravitational force, electric force, and magnetic force as well. We're going to see more on the electric and magnetic force in A2. And then we have contact forces, normal contact force, frictional force, tension, and upthrust. Okay, so the first force we're going to be talking about is the force of weight, or the gravitational force. Now the force of gravity is the force is created between any two objects with mass, and the more the mass, the more gravitational force is present. And we have the largest mass nearest, which is the sun, so we feel its gravity most strongly. The force of gravity on Earth always points down towards the center of Earth, and same applies for other planets as well. And the force of gravity on an object is also called its weight. So this is the equation: weight is equal to m times the acceleration of gravity. Anything else that I want to point out here as well? So one more thing I want to say is going to be that the gravitational force is always attractive. So while the Earth is attracting the mass is also attracting the Earth. Okay, it's just that the Earth is way bigger than the small apple, so there isn't the same effect on the Earth as there would be on the apple. So the apple falls down, but the Earth doesn't because it's a big mass. So that is one more thing. We'll study more on the gravitational force in A2 as well, where we see much more complicated formulas such as this one, G(m)(m) over r squared and all of that stuff. Okay, but the main formula that you have to know here is going to be that the weight is equal to the mass times the acceleration of free fall. Okay, right. Now let's see this apple here. Okay, the force that's shown on this apple is vertically downwards, and this point here is the center of gravity of the apple. Now the center of gravity is where its weight appears to act. So if I put that dot there, and then the weight acts through that downwards. Okay. So we're going to be also studying inclined planes later on. And just so you know, this is not how you draw the weight force. It's always going to be acting down. This is not down, right? So make sure to always draw the force of gravity downwards. Okay. Especially in weird cases like this. Now we'll be seeing some of the units and symbols. So mass, m, it's in kg, and it does not vary from place to place. Weight, on the other hand, is going to be m times g. Now g changes from place to place, so weight is also going to be changing. Okay, this is a force that depends on the strength of gravity. And the units, in terms of the base units and the regular ones, are newtons, because weight is a force. I've got a quick question now. It says two identical balls, each with a mass of 2 kg, are dropped from rest from a height of 1 meter. The ball on Earth takes 0.45 seconds to reach the ground, while the ball on Mars takes 0.74 seconds to reach the ground. Calculate the weight of the ball on Earth and Mars. Assume air resistance is negligible. Okay, so we've got two balls and they're being dropped. Okay, and then the initial velocity is 0, and they've given us other information. We'll talk about that. Okay, and let's take down as positive, up as negative. Okay, we have to calculate the weight on Earth and Mars of the ball. So we're going to be using this formula. So basically we have to find g here on Earth and Mars, and g is basically the acceleration due to free fall, which is also equal to the gravitational field strength. So we just have to find the acceleration in both of these cases. So we're going to be using SUVAT here, and SUVAT here as well. It's going to be 1 meter, so it's going to be 0, question mark, 0.45 seconds. Again, 1 meter, 0, question mark, and 0.74 seconds. We're going to be using S is equals to UT plus half AT squared. U is 0, so this cancels out. And you're going to have 2S divided by T squared is equals to A. I'm going to plug in the values and get the answer then. Okay, so we end up getting the acceleration on Earth when the object is in free fall as 9.87 meter per second square. And then when the object is in free fall on Mars, we get this. Okay, again, air resistance is negligible, so we got no resistive forces here. And I'm just going to plug in the values into the formula and get the weight of the ball on Earth and on Mars. So on Earth it's going to be 19.75 newtons, and on Mars it's going to be 7.3 newtons. So now we're going to be talking about a scientist named Galileo. He dropped a hammer and a feather in free fall. Okay, in free fall. Okay, now I want you to guess which one falls on the ground first, the hammer or the feather. So pause the video and guess. Well, both of them land on the ground at the same time, given that they both are in free fall. So they both will have the same acceleration regardless of their mass. This is a surprising result. Both are in free fall under gravity with an acceleration of 9.81 meter per second. In reality, due to air resistance, the hammer will have a greater downward acceleration. The air resistance exerted on the feather will be greater because of its surface area than that exerted on the hammer. Okay, so just know this as well, that when things fall in free fall, regardless of their mass, they will land at the same time and have the same acceleration as well. Okay, now just one more point. We're going to be talking about things in free fall and not in free fall. Now, free fall occurs when gravity is the only force acting on an object. We do not consider an object to be in free fall when resistive forces, thrust, or other forces are acting on it. These forces cause the acceleration to change according to Newton's second law. So it's no longer going to be 9.81 on Earth, it's going to be changing. Similarly, on Mars, it's no longer going to be 3.65, it's going to be different if the object is not in free fall and other forces are acting on it. So floating in space near Earth is an example of free fall, as the gravitational force will be the only force acting.